Hey everybody, and welcome back to Kerbal Space Program RP-0. We are continuing development of our next generation Mars surface installation, the M97 surface base. It'll, of course, get a appropriate title once it has successfully landed on the surface of Mars. But this is a quick look on what the entire facility, after all of its parts have been successfully docked together on the surface, will look like. We're going to land this as 4 separate modules: the core at the center, the 2 supply pods at the corners of your screen now, and then of course the lab crawler back there in the back of the VAB, and the core habitat module at the center. Like I said before, we do plan on landing all 4 of these modules independently. I should have really done this bit in last week's episode first instead of now, just to kind of give you this encompassing look on what we're trying to go for here as far as how this thing is going to all come together. With the exception of the little rocket pods there on the habitation module, this is pretty much what we're looking at. So we're going to take it outside very briefly and do some quick integration and other accessory tests. That, of course, is the jettison of the landing modules. They're supposed to hit the ground hard enough to blow themselves up, but you know, can't win them all the time, I suppose. And with all the nice lights on, it does make things look a little pretty. There's jettison of the parachute tower and a decoupling of the lab module while we wait for the parachute module to smash into the ground. And then, of course, on reloading, the whole station jumps a couple feet in the air and smashes all the wheels on the lab module, making it entirely immobile. Hooray! And there's KSP once again, dropping the whole station on a couple of feet into the air and then back onto the ground. But thankfully, this supply rover has all of its wheels intact, and so we can kind of demonstrate how our coupling procedure is hopefully going to go. We'll just drive up, bump into it a few times, scrape off some paint, and then eventually get a successful docking to integrate the entire station together. And then, of course, we have our solar array deployment that is on each of the supply pod modules. These panels can be rotated independently of one another just to make sure we get the most sun exposure on those solar panels that we can. So that is hopefully what we're going to be looking at as a total and complete package. Of course, if we can figure out this landing thing, and this is the perturbing part of this whole development process, is that I've been doing a lot of testing for this on my laptop, as I don't have access to my desktop PC for most of the week. Lady Crash has been working from home and taking over the office, so I just don't have the time really to get in and do any actual testing, but I do have the laptop, so I've moved a copy of the save file over there. I know it's kind of technically cheating because since it's not the same save file, I'm actually getting these tests and these simulations run for free. I don't even feel a little bit guilty about it, so there's that. So, but all the tests I've run on my laptop have gone exceedingly well as far as being able to replicate landings and have them actually be successful. I'm actually working on how to capture these modules around Mars, but I would really, really, really like to get a solid demonstration of them working on the desktop PC, because this is obviously where I do all my recording and my Twitch live streaming. So unless it works there, it's probably going to not work when we're doing the whole thing live. So, that's a thing, I suppose. So I did accidentally load in the older variant of the habitat module from the save file, although either one of them would have had to be edited to include the new, I guess, airlock, which is now going to be a Mark 1 command pod instead of the Mark 1 crew carrier, because it does help us bypass the remote tech limitation, even if there's no crew in it. Since it wasn't the first command part placed, we get the benefit of it assuming local control, which is a really weird workaround that exists here in 1.1.3. But again, not sorry considering the complexity of the order of operations needed to actually successfully land this thing, and then trying to time it through remote tech would be even worse. We do have to our advantage, however, that there will be a crew on site at Harmonia Station, and they do have a remote tech guidance module, and we will have the requisite 6 Kerbals on board necessary to provide remote control. So even without the workaround, we'd only be looking at most at a couple of tenths of a second delay, which hopefully would have been enough to execute this successfully. Anyway, we have enough junk in Mars orbit to make it work, I suppose. Junk is synonymous, of course, with comsats. That's what they double as most of the time. So we've gone ahead and started up a simulation and done our deorbit burn and started our coast phase through the Martian atmosphere at a very high AOA. I have found in my multitude of testing with this thing that we can hold between 50 and 60 degrees AOA for most of the descent, which actually does generate a fairly significant drop in our vertical speed for most of this descent. We are actually able to get it down below 35 meters per second total sync rate, which is, for something of this size and massing close to 130 tons, not insignificant. Which kind of brings up the next problem that we're going to have in this development, which is kind of leaning into the next phase, but how to capture this thing around Mars. At 130 tons, it would be absolutely easy to load it up on the BPR, the same rocket that brought the crew and the Chestnut to Mars, and then propulsively capture. However, that launch vehicle is insanely expensive, and we would absolutely go broke doing it. So I think our biggest option is a DN6, which generally it's to Mars capacity as far as payload is just north of 100 tons. So we're about 30 tons over that limit. So we may have to do some reconfiguring to the old DN6, slight changes to the upper stage, and maybe the addition of some solid rocket boosters during liftoff to better take advantage of its really long runtime core stage, and to kind of help out the RD-172 booster engine clusters that get it off the pad. But that is all things that I have not actually delved into. The next problem is that 130 tons is a little beyond what I would consider the upper limit for tonnage we can aero capture at Mars. If we were to have some of our upper stage remaining, preferably just shy of 1 kilometer per second when we get to Mars, we could, in theory, slow down enough with that excess delta V from whatever upper stage it may be to make aero capture successful, and then we'll just aero brake into a lower orbit until we're ready to deorbit and go for landing. However, like I said before, we're kind of at our capacity. We're kind of past our capacity limit for the rocket we can afford. So that's a thing. And also, considering the aerodynamic failures we had last time, which still puzzles me quite a bit because I didn't think there was enough atmosphere at Mars to put that much stress on the spacecraft, I'm a little worried that my initial plan was to put a heat shield just big enough to cover the engine section and leave the rest of the aeroshell exposed during the capture maneuver. But considering the aerodynamic failures we had last time, I'm not sure that's a great idea. We could, of course, up the structural strength of the wing sections that make up the aeroshell, but that's going to cost us more weight. Whether or not that costs us more weight than adding a larger heat shield, and how that excess weight will play into the effects of the aerodynamics during this landing procedure have yet to be seen. But don't worry, I will be testing on those things in the coming weeks. So we're coming up here on our low altitude marker, where we will be firing up that main engine for its terminal braking burn in preparation for parachute deploy, which is kind of where things get a little hectic for me. You can see we are generating plenty of drag, especially that big spike right through the middle, which I can only assume is the engine. But anyway, for all of this stuff, I will turn you over to old me live during the broadcast. 22, 20. We ride it into 15, or no, that's where our first parachute deploy goes. But yeah, we are in the green. That's not bad. 7, 18 kilometers. Sync rate is pretty excessive, so let's just light it up. Boom. Boom. There's our first parachute. If that... Nope, we lost it. Should have fired it up at 20 like I planned. Oof. Secondary should go at 10. God, this is going to be tight. Come on, come on. 11 kilometers. 10. Come on. Where'd they go? Where are my parachutes? Arm. Deploy. There we go. They should have gone to... There it is. Full deploy. Whoosh. Come on. Stage. That did not go as planned. Hello. Paper and feed lines. Seriously? Alright, 6 kilometers. We need to stage off the shell. Oh no, it's not attached correctly. Oh good. Oh good, good, good. Come on. Oh, what in the hell is happening? Why? This makes literally no sense except for lift. Well, this is going to end very, very badly. Let's find retrograde, please. And there's the auto cut. Yeah. One successful test. That's all I've ever wanted. Alright, we gotta fix that staging. God. So in my haste here in the VAB earlier, I apparently attached the top half of the Aero shell to the lower node on the interstage fairing that makes up the top of the Aero shell, instead of the deployment fairing, which would actually decouple. So we'll just go ahead and make that adjustment and then dial it down a little bit to get proper fitment. We will also double up on these so as to avoid any future, I don't know, problems. We're also going to short the fuel here in the lower sections of this stage, because some of this fuel is going to be used for correction and deorbit. So it seems more realistic that we should try to simulate this with the appropriate amount of fuel on board. We are including a Kerbal not because we need the control, but because if we get a successful landing, we need to make sure that the Kerbal can enter and exit the vehicle from ground level, as will be required for all of them to do. If they can't get in and out, there's really no point in them driving possibly days to get to it, which is like problem 5 on our list of problems, is how well can we target a landing site with this thing. I've only ever done targeted landings on the moon, and I guess you consider trying to target a space shuttle onto a runway a targeted landing, but my success rate with those has been pretty abysmal. but let's be real, I've missed continents entirely before, so it's a good bet that the supply pods, the lab crawler, and the crew are probably going to have to drive for quite a while to get on station, as it were. So we are going to have to experiment probably in the next live stream with how accurately we can use Mech Jeb's predict landing site tool to help figure out exactly how many days drive they're going to land off course. I will not be using the automated landing feature. I don't trust Mech Jeb to do any of this correctly, so I will be hands-on the entire descent, although, as you can tell, there really isn't a whole lot of hands-on to do, except avoid physics warp and maintain AOA until you get down to the altitude marker, and then things go a little crazy for a minute or two, but then hopefully you get a nice soft touchdown, which I guess, yeah, we have yet to realize here on this channel. But I have my hopes. I hope y'all are rooting for me. Even if you're rooting for this to fail, just, you know, I appreciate all the cheers. Anyway, so during physics warp, it does go a little bit wonky, but, you know, everything goes a little wonky in physics warp for the most part. If we don't use physics warp, it's actually pretty dang stable, and you can do most of the descent pretty hands-off without it pitching, yawing, and wrenching around all crazy-like for most of it, which I think when we do the actual landings is probably going to have to be the standard procedure, because especially if we're trying to target things, we're going to need to keep our descent slope and our sink rate predictable when you're pitching back and forth is, yeah, kind of like this. That doesn't make for good predictions. It makes for wildly off target. Although, when we did try to land the food pods for our last Mars landing attempt that didn't go so well, Mech Jeb's landing prediction thing was actually a very, very useful tool, especially for such an off-plane transfer to the landing site as that, and we're really only about 250 some odd kilometers off target, which, all things considered, for me, that's really not that bad. I mean, that's pretty good. I would take a couple of hours behind Mech Jeb's rover pilot tool thing than, you know, a complete failure. Anyway, we're coming up on our low altitude, so I'm going to turn you over to old me. We can actually stall out that sink rate at like 20 degrees. God, I wish I could maintain that. So I think we are going to have to add the second set of thruster packs to the top here and link them all together somehow. Oh, 19 kilometers. Fire the engine. Ba-boom. Now we can mitigate as much sink as we want. So we actually come into this with more than a kilometer per second of DV. I'm going to be extraordinarily happy, but at this point I just want to get a successful landing. I don't have inflatable heat shields though. This is what makes me so mad. 6 kilometers per second entry won't give you flames. That could be... There is primary deploy. Please don't snap. Please don't snap. Yeah, it's not going to snap. We're good. As long as nothing else fails, we're going to be just fine. We got another 13 seconds of runtime. Alright, let's just go ahead and kill this here. Stage it off. Goodbye. That is what I like to see. Get out of the way. And this stupid shit again. Never happens anywhere else but here. For the time being, we're going to kill RCS. Oh, please don't let this come back to bite us. Please don't let that come back to bite us. This should snap us in line. Please, 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 snap us in line. It's trying. It's trying really, really hard. There we go. Yes. 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 All right, we're going to get down to about 5. Actually, we should stage it off now, just to make sure. All right. Come on. Next one up. Go. Where are my parachutes? Did you effers not arm? There they are. Thank God. Gear out. We're still accelerating. Oh God. What's the primary deploy altitude of these? There it is. Yes. Decelerate, my friend. RCS back to arm. 1.4 kilometers. We have a lot of speed to shed. And there's our lower shell hitting the ground. If you hear the explosions off in the distance. Alright, we'll lay off the RCS for a minute. We're down to 12.8, which is... Oh man, that might land pretty close by. Except the chutes are going to cut at 1 kilometer. We know this for a fact because it happened to us last time. I'm really sorry, chat. I will pick up all of the messages here as soon as we're safely on the ground. 800 meters. 4 minutes of runtime. We're looking pretty good. 700 meters. Did those lights... This one doesn't have the lights. Where are my lights? Ah, that's right, because I loaded up the old one. Son of a bitch. Now I'm gonna... Alright, well, we're gonna have to add the lights when we get back in. Because I'm not doing this without surveying lights. 11 meters per second down. 300 meters altitude mark. RCS assist. Dial this in. Nice and easy. Come on. Nice and easy. 150 meters mark. $90 meters. Oh, there's a bunch of stuff hitting the ground, and we're losing it. We're losing it. 30 meters. Touchdown. Yes! It's on a big stupid hill, but we did it. Hooah! Don't tell the devs. Not totally sure the Aero shell is a stable shape. Like, it would probably rather go nip first. It might. I actually have trouble making it go nip first. But, it does sure like to put its butt in the air. Design a VAB, but... Bagging KSET build before research done is bad. Is this going to land with a crew? No. Once it's landed and assembled, then we fly the crew down. You're just barely losing speed on chutes with full engines is kind of terrifying. A little bit, but with RCS aid, or with RCS to aid in descent, touchdown can actually be a little bit slower than this. This was what I would call a rough landing. You're missing only a cockpit. You could start KXT build without it, and then edit the cockpit when an R&D is done. Nice. Thank you, thank you. Street Fighter, perfect. Alright, Niman, thank you so much for coming by, man. Much appreciated. So, alright, we'll do that second. Let's jettison. Yep. That's going, and then we'll pull in the gear. Thunk. Bounce on our rig. Are we sliding? Apparently, we're moving at 0.03 meters per second. Oh, good! Good, it's going to slide downhill. This is awesome. This doesn't have the set motors. They didn't even separate. How are you still connected, my friends? This was the problem. Yeah, enable crossfeed. Because we fired the decoupler already. That's why we have the motors that face down and burn these things off, is because now they're stuck there permanently. So all these changes that we made to this to make it work, I'm going to have to redo on the real model. Because this is the earlier prototype. But, hey, that worked. And now we're stopped. And everything works. And this probably still has a bunch of supplies in it. No, it doesn't. Okay, good. Yeah, these are all supposed to be stocked up. That's awesome. Extend ladder. Let's make sure we can get in and out of this thing. Yay. How long we got? An hour and 24 minutes. I bought way too much simulation time. Yay. Woohoo. Alright, now let's make sure you can get back in and that you can transfer to all the places. Because that's what we might need to see. Board, yes. Transfer, I like to see all this green. Yes. Perfect. We can move crew around. We can land. Thank God. Whew. And there you have it. One mostly successful touchdown on the surface of Mars. So I think we're ready to move this past the prototype and into production. We just have a few small changes that we need to make in accordance with the previous prototype schematic. And that includes the surveying lights and the separatrons to make sure that these stupid descent engines can get properly severed. So we'll attach these solid rocket motors, angle them at the decouplers, give them a thrust limiter to make sure that they're in place long enough to burn through that decoupler or the metal octagonal strut that holds them in place, and save this thing under a very unique name so as to not confuse it with the failed prototype that we flew last time, although it's pretty much the same. Anyway, that's going to do it for this episode, everyone. Thank you so much for hanging out. I really do appreciate it, and I will see all of you in the next one. So until then, see you later.